Hi, everyone. Welcome to SuperAnnotate CV Automated Pipelines webinar series. My name is Dave, and I'm the project coordinator for this series. Today, it's Epoch 1, the grand opening. And my co-host for this series is Oscar, SuperAnnotate's head of AI solutions. Oscar.
Hello, nice to be here, everyone.
A few words about our series, why we want to do this, and why we're so excited about it. Data annotation is a critical step in supervised learning, and working with thousands of different companies at SuperAnnotate and on all sorts of projects, we've seen firsthand that a lot of folks are missing the opportunity to significantly improve the efficiency of their computer vision pipelines by leveraging annotation automation methods. Throughout these years, we've gathered a lot of experience, and the purpose of this series is to share some of that experience, as well as the best practices that work for us and automation methods that are conventionally accepted by the ML community. An important underlying tone of our webinars is that we're not suggesting that there are no better ways or alternatives for annotation automation, or that the methods that we'll be sharing are universal and can work for any project. A great way to think about our webinars is a building blocks or as an inspiration for automating your own pipelines. Understanding that the topic is quite large, we've broken our content into 6 epochs that will be covering specific areas of knowledge, with each epoch providing a foundational piece of the annotation automation puzzle. Now you're on epoch 1, and today Vasco will cover some of the essentials just to refresh your understanding of annotation automation. And in the second half, we couldn't miss the chance to do a panel discussion with our speakers. Through epochs 2 to 5, we'll be diving quite deep technically, and each epoch is dedicated to a specific automation use case, and it's hosted by one of our speakers. And the very last webinar of this series, epoch 6, is going to be a wrap-up with our co-founders. To get the full understanding and the best experience, we recommend joining all the epochs, or at least checking the recordings. At the very end of this series, we hope that you'll have a decent understanding of the methods for building scalable and efficient data pipelines. Before we dive in, a few housekeeping notes. Before each epoch, you'll receive an invitation with the Zoom link and any other additional information. As always, we're recording these sessions, and our reps will send the recording over to you after the webinar. Also, as said, we'll open up the chat for Q&A and discussion, so feel free to drop your questions. Just in case we don't manage to reply to it live, we'll send the answer in the follow-up email. I was just going through the list of attendees, and I did notice a lot of our clients here. But for folks who might be new to SuperAnnotate, I want to give a quick introduction. As SuperAnnotate, we help companies build the highest quality data sets for all sorts of machine learning initiatives. Bahan and Tigran founded SuperAnnotate back in 2018, and so far we've raised 20 million from well-known institutional investors, with our latest round being the highest Series A raised in the field. We've grown into a 150+ team of computer vision enthusiasts across the globe, with representatives from the US, Japan, Philippines, Sweden, Armenia, Ireland, and Bangladesh. We're recognized as one of the top 100 AI companies in the world, and we are the top ranked platform in the data labeling category on G2. Essentially, SuperAnnotate is a unified annotation environment consisting of 3 main components. It's our data operations platform with advanced tooling and QA, data management and exploration systems, acceleration and automation features, and a robust SDK for deep pipeline integration. Then, on the other hand, we have our curated services marketplace. We've screened over 400 annotation workforces around the world and selected the top 35 to participate in our network. On top of all that, we provide an expert team of project managers, annotation experts, and ML engineers to help you design, execute, and manage your annotation projects with all the best practices we'll discuss today. The AI customer success team, with maniacal attention to the details, coupled with excellent ML ops expertise, can serve as the extension of your data engineering unit. Bringing this together, we'll build a unified annotation and data management environment optimized to provide best integrated software and services experience, leading to higher quality, quality data and more efficient data pipelines. I think this was all on my end, Oscar, and I'm happy to hand this to you, please.
Thank you, Dave. Wonderful. All right. So as Dave said, we'll be happy to take some questions and just drop it in the Q&A part of the Zoom here, and we'll be happy to review them. But let's give us an outline of what we'll be talking about today. So this is just the first part, like the grand opening of this series. So what I want to do today is just cover some cases of defining what we mean with manual and automated annotations. Talk a little bit why you might like to be interested in that and when it might be used. But also dive into some use case that we can see today. Like one example, we'll be talking a bit about the using predictive labeling to help with annotations. And then we're going to talk about some fully automated annotation, if that works or not. And then we'll talk to the rest of the team as well and wrap up this webinar, first one in the series. So first out, let's start defining what we mean with manual and automated annotations. So when we're talking about this, the manual annotations we're talking about is when we have humans manually placing the labels that might be needed. It can be for any type of task, for computer vision, text, or anything else you might see. The thing here is that it is generally quite time consuming as any annotation work because it takes time to place all of this manually. And it will of course be costly because it takes time and we need humans in the process. It is quite low tech, which can be quite good, though usually a robust platform is needed. So it's not as low tech as some people think. But it doesn't require as much development on the models that might be needed on the automated side. It can also be very accurate. There are things you can put in place to ensure that it is more accurate, but to achieve 100% accuracy, you would need to have a manual labeling process involved because we only want the models to emulate what people basically are doing during the annotation process. And yeah, we can't really achieve that. So if we turn to the automated part, that is usually a lot faster because we can of course involve machines in the whole pipeline. And we can just run through a large data set quite rapidly. And thus it also makes it a lot cheaper because we don't need any humans there. It is more high tech, which sounds cool, but it does require more development to make sure it works. And the accuracy of these annotations would be model dependent. So depending on which approach you take, the accuracy would depend a bit on that model. And I don't see these two as mutually exclusive, but they're quite complementary. So as we see here, we talked about this in a previous webinar, the kind of things you can add on top of the annotation process to make it better. You need to have a manual part of the annotation process to make sure that we are validating everything, but you can add automations as sort of the icing on the cake and make the final touches to make it the best it can be, to add quality and reduce speed. There are other things we've mentioned in other webinars like interpretation of instructions and effective workflows as well. And those are also part of things that can be part of some of the kind of pipeline automations that can be applied. But for annotation automations, that's something else that might be added on what we will be talking about today. So I think the why you would be interested in automated annotations is quite clear now. It will bring you faster and cheaper annotations. So you will have a faster turnaround time once you get more data. It will be faster for you to go from the unlabeled dataset to a labeled dataset, and the process will be cheaper. So with the same budget, you could also get a lot more data. And that's always something we assume that you guys are looking for. So with this in place, you can keep humans in the loop only and not rely on those processes for 100%, but we are complementing the humans' work by adding help with automated annotations. And how this can be done can vary a lot. That's why we have this whole series. So during this series, we will cover a lot of different cases of how you can think about automating it. For example, the automation suite for OCR, box to Polygon instance classification, a lot of cases out there, and we'll dive more into them deeply in the other sessions. Today, we'll talk a little bit about utilizing an already pre-trained model. So in most cases, I believe people have some kind of model already, whether it's fully fresh or that it has been pre-trained on something at least. In many cases, we see that our customers have a model in place, or we can quickly wrap up a model by annotating some things manually. But here we are thinking about using the end goal model to help with the annotations. We are taking the predictions from the existing model and using it as pre-annotations. So we don't expect the model to output 100% accurate results, but the results that they output can help in the annotation process. So instead of having to place every annotation from the ground up, we can have the model being quality checked by people, basically. And within an iterative fashion, we can improve the model over time, so it will become better and better. And thus we can automate the annotations more moving forward. But we can also find the areas where the model is not performing as well and focus our annotation efforts in those areas. So we are really focusing on the pieces where the model will improve the most. And that's all about the kind of active learning framework or mindset, which we also had another webinar about. You can more than happy to take a look at. But to show you all how this can be done, I'm going to go over to our SuperAnnotate platform to give a brief rundown of what it might look like. So what we have here is a team in our platform. It's been used a bit during the active learning webinar. You might have seen it during our bias webinar as well, but now it's here during the automation webinar too. So let's explore this. What do we have here? Well, we have a project. It's going to be a object detection task we're going to focus on, and it's going to be about grapes. Let's take a look at it. What we can do here is look at some versions. Since we've used this for some cases, I have the newest version right here of our dataset that we will take a look at for this automation webinar. And we can explore it a bit so you have an understanding of what it looks like. So the dataset consists of wine grapes or grapes and in a vineyard. And it's an object detection task to decide also the variety of the grapes. So we have some cases of folders here of training data. And we also have some semi-labeled data, so to say. We call it the pool set. So this has been unlabeled to start with, but some of the images have been labeled. And how they have been labeled is by my wonderful colleagues, some of them on this call, but also with the help of automated annotations. And how do we do that? Well, in the platform, we have something we call our neural networks section. This allows you to quite rapidly spin up a model and train it on some data sets and then utilize it for these kind of tasks for automating annotations. So what we did was that we quickly trained a model to detect the varieties in this training dataset, the initial 200 images. And in the platform, it's very easy to do. We can create a model. We can choose the annotation task. In this case, it was object detection, and the training data and test data, for example. With this model, we can see that it's what I would say at least performing quite decently. We have an MAP here of around 35, better or worse for some classes, but it's not too bad at least. And we can now use this one to speed up our labeling process. So if we go into what we have here as the pool set, we can see that some images are in the status of completed. They have already been annotated, but there are some which have not been annotated. And if we take a look at this one, say right here, we have a sample of an image, and how we do this is that we're now going to utilize the predictions from this model to help with the annotation process. It can quite easily be run by just selecting the model right here. And now we are going to run the model to get the predictions. It's of course easier done in bulk, but you can also do it on one image at a time. If we're now going to review what we have here, let's see how well it performed. Well, on this one, it didn't really do anything, but we have some other cases here where we have some actual predictions made from the model. So as we see here, we have a model that is not performing 100% accurately. And then we can't really expect that the, that the annotations will be, performing at any specific rate. We can have some help. Sometimes it does not give all that well of a help, but that's why we want to improve it, right? So we'll see in this case right here. No, not really. All right, bad examples to show it. I'm sorry for that. But basically what we can have here is a case of annotations helping us in the process. We can think about it as the case of these annotations already being done by the model. These are the predictions that we get, and we can then fine-tune them manually and quality check their work. So what I might do is that I want to add some more annotations, make sure that they are correct. I can give the right class, and I can then correct the annotations that might be wrong. Make sure that this one is correct right here. And with a workflow like this, we can annotate more data and then train a new model. So I believe quite strongly, and I hope I won't regret this later, that the new model will perform better. So this is a new model that we retrained on some of the label data. And this is what we think as a good process to work in, right? We're labeling some data, we are improving the model over time, and now we are retraining it again with the newly labeled data. And what we can see here is that we have better scores for the annotations right here. So the model is performing better, and we can then use it in this case to get some annotations instead. So fingers crossed. Let's see here in this case right here. We'll run the new model and see if there are any cases of predictions that we can see right here. And as we can see, yeah, everyone takes a deep breath. It all worked out. Well, as we can see here, we got some annotations, and this is something we can now use or has as this first step in the annotation process. I don't have to place everything from the ground up, but I can use these things to improve the annotation workflow. So I just have to edit these, perhaps add some new ones, but it will help in the pipeline and reduce the time spent. So that's how we can, for example, help to speed up the annotation process. So going back to the slides, when should we do this? Well, we need some manually annotated data. And the more, the better, of course. And as we saw with some small samples, we might not get a model that is good enough. We don't have this decent performance we are looking for. So we only have to label some more data manually, and then we get to the certain threshold where it's going to be more and more usable. The thing here is that when you might want to use this is also what I call it. It's depending on the setting. Some settings are usually better to use this than others. The case we had with object detection is a great use case where it is quite useful. The case might be that some of the objects that we are detecting are detected accurately, and that is great. We don't have to change anything. While some we just might need to change a little bit, and we might have to add some of the, say, false negatives that we didn't really find. So object detection works well. It can be more difficult in some other settings, like in segmentation. When we're doing a pure segmentation project and we have very high quality requirements, we might need to touch up the polygons quite a lot, or touch up the segmentation map quite a lot, because these predictions are probably going to be quite good, but are they actually going to give you that quality requirement that you have, which is a pixel perfect mask? That can be quite difficult. And then editing the actual mask around an object might take as long as placing it manually from the ground up. So those are some of the considerations you can take into account when doing something like this. Then I think for the last question, like, can we fully automate the pipeline? And I would say no, that doesn't work. So it doesn't really make any sense to fully automate the pipeline, because if you can't fully automate your annotation process, you would not really need any annotations. The aim of the annotations would be to provide a ground truth to your models, and you can then use that to try to train the model to replicate that behavior, basically. And if we can fully automate the annotations and create the ground truth, we probably already have a model that performs as good as we want to. So it's good to keep humans in the loop here and make sure that we are always having some people to quality check the results, and we can use the automations to help in that process of getting the annotations, helping it to being a bit faster and cheaper. but not fully replacing all the humans. Great, wonderful. So I'd like to stop here and check in with everyone if anyone has any questions, or should we jump right to the perhaps presentation of the team instead? And you guys can write some questions in the in the Q&A right now and gather your thoughts.
Thanks a lot, Oscar. I think this was a great coverage of the essentials of annotation automation. I actually have a few of my own questions. At meantime, folks, please drop your questions. And let me start this off. Who's everyone? Welcome, Sally Ann, our AI solutions engineer. So Sally Ann, I mean, on daily basis, you're in touch with computer vision engineers in the industry, right? And what are the main areas where folks are really struggling to automate their processes?
Yeah, great question. I would say that the most common areas we see clients struggle with in terms of automation are automating their ML pipelines. So meaning processes such as loading data from storage, pre-processing, things like that. And then two would be annotations. So as Oscar discussed, being able to do things such as interpolation of objects in videos or doing auto detection of objects. And then lastly, maintaining a clear link between models and data sets used to train them. So I'd say those are the three main areas we see clients struggle with the most.
Well, a quick follow-up on that one. So what are the problems that clients are trying to solve with this, automation?
Yeah, absolutely. So I would say that the main problems are usually a chaotic workflow, annotation efficiency, insufficient workforce, and then a big one is cost. And,
awesome.
Some advantages to that. When you're annotating or automating your CV pipeline, you're able to improve your overall workflow. So rather than having multiple tedious and often manual steps in your workflow, you can automate these various steps so that it runs seamlessly. Whether it's pulling data to be pre-processed, automatically pushing new instances for annotation, converting annotations to be modeled, or even just performing some post-processing. We can automate these parts of the pipeline. And then this shifts your team focus away from these tedious manual tasks to other tasks that require more time and human interaction, such as building your actual model or doing model optimizations. And then when it comes to the automation of the annotations, one of the main advantages, as we touched on, is reducing the amount of manual work needed. So it saves you time and money. And so rather than using a workforce for initial annotations, you can leverage this auto labeling so that initial annotations can be just checked by a QA, and it removes that entire manual step from your process.
Awesome. Well, thanks a lot, Sally Ann. Next up, I want to direct my question to Luis, another one of our AI solutions engineers right on our webinar. So Luis, so can you maybe talk about different levels of maturity building MLOps pipelines? We do understand that different folks are different levels, obviously, depending on a task and then depending on a specific time spent on this specific project. But can you please elaborate more on these levels?
Yeah, absolutely. Thanks, Dave. So before I begin, I just want to mention that this is a current area of research, and it's growing pretty rapidly. So there is actually no real general consensus of how to deal with the pipelines and creating them. But with that being said, I think the consensus for now is that there are 3 levels of maturity. I'll start with level 0, in which case the entire pipeline is it's manual. So you have the machine learning training, you have the data preparation, you have your exploratory data analysis. All of those steps require manual execution, and transitioning from one step to the other is also done manually. And in this first level of maturity, there are infrequent release iterations for the models. So this means that you may be putting out a couple models a year to your pipeline, and also you have no continuous integration, you have no continuous delivery for the models, and also there's a lack of active performance monitoring. So you can't really get much insight into how your model is performing, if there's any drift or anything of that sort. That would be the most basic level of maturity. After that, you have the level 1, in which case you have part of your pipeline automated. And the part that's mostly automated in this level is the machine learning portion. So in this case, you can rapidly experiment with new model architectures, different types of data that you input into the model. In this case, you also have continuous training of the model that's going into production. You might also have modularized code for the different components of the pipeline. And then in this level of maturity, you're actually deploying pipeline instead of just deploying a model for your end user. And finally, for the last level or the highest level of maturity, you would have the whole pipeline pretty much automated. So you automate your machine learning portion of the pipeline, and you also have an automated portion of continuous integration and continuous delivery. So in this case, you're also able to not only work on the machine learning portion of the pipeline, but you also have the operation portion completely automated. And you can continuously integrate and continuously deliver new models to production. There may be also some automated triggering and monitoring that allows you to actually measure the performance of your models as they're actually live out for the end users.
Awesome. That's quite interesting, I should say. I noticed that in the Q&A section, someone asked whether we're recording the webinars or not. Yes, everyone, we're recording the webinar, and we'll send the recording shortly after the end of this session. Well, awesome. I want to address my next question to Armin, SuperAnnotate's ML researcher. So Armin, now, how do you typically come up with ideas for automation, right? Is it something that you take this use case from our clients, or is it something that is it's something that is being discussed in the community, in the computer vision community? What's your method there?
Thank you, Dave, for the question. Actually, it's a combination of multiple reasons, including the ones you mentioned. So first of all, it's a good practice to in the community to create some instructions list or some pipelines for new features or models that other users will be able to use that much easier. Secondly, we spoke with our clients to understand what kind of automation tutorials they will like. So that tutorials will help them to integrate to our platform much faster. And finally, whenever we encounter a task that is quite repetitive, we tend to develop methods for automating them. So all this together made us to create those automation pipelines.
Awesome. Thank you. Thanks a lot, Armin. Next up, Arsina, our ML product researcher. So Arsina, are there any use cases where, well, it's much harder to implement automation, right? For example, I imagine that algorithms for computer vision applications might not have the same robust automation suites as for the NLP, right? So can you tell me more about that, and to the audience?
Sure. Hey, everyone. Yeah, that's a great question, Dave. I would say, of course, any automation pipeline is limited to the tools and algorithms available in each research area. For example, if we take NLP, each language has a basic set of rules which you can use to match the context that you're interested in. Let's say you have a document and then you want to predict the violence in it, then you obviously have a set of keywords that you can look for and match those as rules to detect the context. But if you're talking about the applications in computer vision, there is no sort of predefined generic model that will get you the object of interest in any scene, whether it be an application in medicine or somewhere else. So in that sense, it's much harder to build a robust automation system for the computer vision versus NLP. And then here, I would like to also point out that not only the tools and algorithms available in each research area restrict each automation pipeline, but also a whole infrastructure around the area. Let's say we're looking at the problem of OCR, then of course the datasets are always private there because we deal with the documents. And even if you take a model that was trained on synthetic data, it won't give you any useful results for automating. You have to retrain it for your own set of documents that is, let's say, for the application of receipts in supermarkets. So I would just summarize this that first, the limitation comes from the algorithms and tools available in each research area. And then the second, the whole infrastructure around it. Something like this, yeah.
Awesome. Thank you, Arsenia. Next up, I want to ask a question to Vahag. Vahag is an ML engineer at SuperAnnotate. Vahag, so a lot of folks in the community are quite excited about the self-supervised learning approach. So what's the advantage of this approach compared to normal supervised learning, right? Is there any, maybe there are some use cases when it's self-supervised learning is the go-to algorithm?
Okay, so let's unpack it step by step. The main advantage of self-supervised, well, as well as unsupervised learning, is that it enables AI systems to learn from orders of magnitudes of more data. In case of supervised learning, the amount of available labeled data is an obvious bottleneck for the things that you can do with it. And basically, that's why our platform exists, to make more labeled data. However, self-supervised learning treats all the available data in the world, all the text, all the images, all the videos, all the audio files, songs, whatever, in existence as its own label. This assumption of data itself being a label paired with the abundance of data is important to make the artificial intelligence models recognize and understand patterns that are a lot more subtle than just features that are present in a cat or a dog, let's say. I said that it uses its own data as its own labels, but what does it actually do with it? The general technique of self-supervised learning is to predict any unobserved or hidden part or a property of the input data. A real-life example would be predicting missing frames in a video. Let's say there is some live stream of a sports event, and as a live stream, it's transferred through a lossy channel or a protocol like UDP, and it makes sense to have a model that could predict all the missing frames so that the viewers can have a more fluid experience watching that stream. And an NLP example would be masking some parts of the word of sentences and trying to reconstruct it. Let's say a sentence like, I've been born in France, therefore I know how to speak in, and the model would say French. Masking some parts and then having it predict them, basically that. And then another go-to field for self-supervised learning is to create some kind of background knowledge set of subtle features that can be used in other paradigms to create a supervised model that can escape a performance plateau. As you all know, probably, this paradigm that more data, more labeled data equals and larger models equals better models, better performance, starts to sort of plateau, starts to not be as true once the models get very large and data becomes a lot. So you can imagine extracting a lot of features and helping other models solve this issue. Yeah, and an important thing to know about self-supervised learning against unsupervised learning is that self-supervised learning is predictive. It's exactly for trying to find things that are unknown and extrapolating it, whereas unsupervised learning tries to infer some information about the data you have, like say clustering. Cats are similar to each other, dogs are similar to each other, and so on. That's about it.
That's awesome. Thank you, Vog. That was very interesting. My next question is Eric, ML engineer here at SuperAnnotate. I think we had a question about this. So Eric, another trending algorithms these days is active learning. For folks on this webinar, we actually had a dedicated session about it. But then I would just ask Eric to elaborate a bit more about it. and yeah, to address this specific question that we had in the Q&A. Eric, please.
Yeah, hey everyone. Yeah, Dave, as you said, active learning is a very trending method right now in the community. And so to elaborate more on that method, in a nutshell, active learning is an interactive method that allows machine learning algorithms to iteratively query new samples to be labeled by annotators, and then improve the model performance with the help of these newly labeled samples. And if we try to sketch this pipeline of these active learning methods, it would be like the following. Usually they start with a small labeled set, with a small labeled set of samples, and then they train a model on this small data set, and then using this trained model and also some kind of informativeness heuristic, they select new samples of from the unlabeled pool to be labeled by human annotators, which are then added to our small data set, and we again retrain our model, and this cycle continues several times. And usually when a good heuristic of informativeness is chosen, after repeating several cycles of these trainings, the algorithm reaches the performance comparable with the case when if we used the whole data set and if we labeled it all. And so, as you can guess, they can be the main advantage of these algorithms is that they drastically reduce our costs, both the annotation costs, because less data is needed to be labeled in order to get a good performance of our model. And also, if we utilize less labeled data for our trainings, less computational resources are needed. And so again, our costs are reduced in this case.
Awesome. Thanks a lot. Thanks a lot, Eric. I think this made a lot of sense. I see that our panelists actually went ahead and replied to most of the questions, at least in a written form. Oscar, do we have anything that would like to cover live?
Yeah, I think like everyone else can chip in here as well if there's anything. But I saw that there were some questions about both corner cases, automatically detecting them, and some other stuff as well. So like I think if we start at the corner cases, that is of course difficult to detect. I know that active learning there can absolutely help. We can see where we might have low confidence predictions. We might have something to flag that there is a edge case or something that we want to investigate further. The actual false negatives is a bit harder to find, and that's partially also why we also need this fully human participant to always be part of the process, right, to understand these cases. And we can have some applications to kind of curate the data on a higher level, not necessarily dive into every image, but we can do reviews like in the curation mode that I showed in the beginning, to have a high level overview of the data. But generally we need people to review the data. That's what we always use and what we find to be the best practices in general. Right. There's also a question about what the most important thing is, if it's pipeline automation or auto labeling automation, and if we are relying on pre-trained models. And I think for the auto labeling, we'll see in the other webinars what you can rely on that are not only like pre-trained models, so to say, but pre-trained models will be in this setting at least, a key, like a cornerstone. We are going to use pre-trained models, but we're going to fine-tune them to your data. So basically you are starting to do the model development work before you have all of your data annotated, and keep improving that over time. But whether the what pipeline automation or the auto labeling is the most important part, it's difficult to say. I think both of them are very important. Like the pipeline automation can save you much more time than automating the annotation in many cases, and the other way around. But I would say that the pipeline automation would be like a key focus to try to get a grip on first, to have a thorough, like a good MLOps pipeline, basically to go from idea to model to the annotated data and have a good pipeline for integrating that data, going back and forth. I don't know if anyone else on the panel have anything else to add when it comes to the kind of trade-off between pipeline automation or automated annotations.
Yeah, I'll chime in here. I would hesitate to even compare them. I think, like you said, they're kind of both equally important. And together, it really is the best way to optimize your entire ML project. So being able to automate most parts to reduce the amount of time that you're spending doing manual work is always a good thing. But of course, always having those human interloops are necessary for, doing QA or checking for model optimization or model building. So by automating, again, you're being able to focus your time on those pieces of your pipeline that require human interaction.
Wonderful. Let's see, are there any other, so I think most of their questions, yeah, they kind of, I think, detailed outline for the next session's presentations. I'll leave that to you a little bit, Dave, but I suppose we will keep people informed with what is going to go on in the next couple of sessions, at least, moving forward.
Yeah, absolutely. On our superannotate.com/webinars, you can find the timeline. Oscar, if you go to second slide of this presentation, I think we should have it there as well.
Yeah.
There we go. Folks, this will be our timeline. Yep.
Yes, I guess to just expand perhaps a little bit here, the next session will be about the different automations for OCR application, recognizing location of text and text content in imagery. We'll have instance classification, so classifying different objects. You'll find out more about that. Box to polygon is the idea of placing a bounding box to generate a polygon around an object, and dive into that setting more. And then about video predictions for working with video data instead of just pure images. So there's a lot of interesting things that are gonna happen in the future. So keep updated.
I think we had a question about OpenCV and SuperAnnotate. I think Arsina, do you have a good reply to that?
Yeah, thanks for the question. We had a pretty exciting cooperation with OpenCV last year as they released the OCD device. So around that, so basically it's a device with an in-depth camera that you can put your models on and run inference. So what we did, we basically released a series of tutorials with OCD and SuperAnnotate platform plus our SDK, which you can use to first take the images to the platform, then train your models in it, and then use the deployment tutorials also available in our open source GitHub page to kind of squeeze the model and put it on that device. So I think it's pretty interesting to play around. We have use cases covered for object detection, segmentation there, a couple of models for, I think it's SSD and YOLO for object detection and DeepCloud V3 for segmentation. Eric is the owner of this tutorials, and I think there is a lot of discussion and community in Discord for this. So feel free to join this. Maybe we can share all this information later on after the webinar, and you can use it to make your life easier to work with different versions of leaves as it's common in ML. Yeah, that's it, I think.
Awesome.
Great. Perhaps I'll take the time to just wrap up a little bit some things that we talked about here. So thank you for joining. I think some things to perhaps take as a key takeaway would be that it's worthwhile to try out with automating the pipeline. Oh, give me 1 second. That's fine. So automated pipeline, try to give it a go. It's worthwhile because you can integrate like a model into the annotation process, and it's not going to hurt you in any way. You're already going to develop that model anyway, so you can keep it there, improve it, and help it with the annotation process. But keep humans in the loop and make sure you have people involved to quality check the results and make sure you have a good high quality data set out in the end. And yeah, make sure to stay updated for the next sessions. We'll have some other interesting topics to cover when it comes to this. Yeah, thank you.
Thanks everyone for joining in, and we're hoping to see you at our next webinar.